Let's play a little guessing game. I'm thinking of two numbers and I want you to guess what the numbers are. I'll give you a hint. The sum of the numbers is 5. Well, you look a little puzzled. Yeah, I really didn't give you enough information. There's an infinite number of pairs of numbers that add up to 5. So let me give you another hint. The difference of the numbers is 3. Yeah, there's a lot of pairs of numbers that have a difference of 3. So how do you find the pair of numbers that makes both statements true? There it is. If we use 4 for our first number and 1 for our second number, we have two statements that can be true at the same time. 4 plus 1 is 5, and 4 minus 1 is 3. That was quite a guessing game we had to do. There's actually an easier way to find the pair of numbers that make both statements true. Another thing we could do is look at the two statements and think of them as equations that we can graph. The statement the sum of the numbers is 5 is described by the equation x plus y equals 5. That's a line, and if we find points on the line and graph those points, we can have a picture of all the pairs of numbers that make that equation and that statement true. We'll do the same thing for the other statement. The difference of the numbers is 3 is described by the equation x minus y equals 3. We can find some points, some ordered pairs, that make that equation true, and then when we graph them, we'll have another line, another picture of pairs of numbers that make the equation true. There's a point that both lines have in common. That's the point 4, 1. That's the solution to the system of equations. So when x is 4 and y is 1, both equations are true at the same time. That's what makes 4, 1 the solution to the system of equations. So as long as we can graph the lines that make up the system, and we can figure out where the lines cross, we'll be able to use a graph to find the solution to the system of linear equations. Let's try another one. We'll graph the lines y equals 2x plus 1 and y equals negative 3x plus 6 on the same coordinate plane. Y equals 2x plus 1 is a line that has a y-intercept of 1 and a slope of 2. And y equals negative 3x plus 6 is a line that has a y-intercept of 6 and a slope of negative 3. The two lines cross at the point 1, 3. So 1, 3 is the solution to that system of linear equations. That means when x is 1 and y is 3, in both equations we get a true statement. Now let's look at one more system of equations. The first line is y equals 3x minus 1, and the second is y equals negative 4x plus 3. If we can determine where those two lines cross, we'll know what the solution to that system of equations is. Y equals 3x minus 1 is a line that has a y-intercept of negative 1 and a slope of 3. And y equals negative 4x plus 3 is a line that has a y-intercept of 3 and a slope of negative 4. The two lines cross at a point, but what's the point? It's really hard to tell where those two lines cross because that point doesn't fall on the grid lines. That means the x and y coordinates of the point aren't integer values. In fact, all we can really tell is that the x coordinate is somewhere between 0 and 1, and the y coordinate's also somewhere between 0 and 1. So even though we know that there's a solution to this system of equations, we can't really tell from the graph where it is. So we'll have to find another way to solve the system. We'll learn other methods for solving systems of equations another time. For now, just remember, if the two lines cross at integer values for x and y, you will be able to find the solution by graphing.